Student, now we are going to see the second portion of paper chromatography. In this we will see about the pictorial aspect of the different development. So let us see the different type of picture in which we have discussed in the previous slide, the ascending development and descending development. In ascending development you can see it here, the solvent is at the bottom, and then paper is kept or dipped into that, and the solvent is flowing, or the mobile phase is flowing against the gravity. And in this, the solvent move with the help of capillary action, and it is very slow process, so it is time consuming. Whereas in descending paper chromatography, you can see it here, it is a special chamber. The paper with the spotted sample is put into the solvent of a special design, in which the solvent is at the top, and the solvent here, or the mobile phase, move with the with again with towards the towards the gravity, and so that the flow is faster as compared to descending one. The third, we can see ascending descending chromatography. In this we have a two phase. In the first one, you can see that solvent is at the bottom, and at the when it moves till the top, then the solvent is at the solvent is at the top, and then it moves against the towards the gravity, and sample is separated. So what happens, the sample here gets two time run. So when there is a two time run, obviously there will be much more separation between the two compounds, and then it could be easier to identify when they are closely related, or when they have a similar type of binding affinity, and varies in a very small proportion. This is generally when you have a isomeric type of a compound, or compound are very closely related. Third, we have here in a pictorial form, we have seen a circular flow of the the sample is a circular paper, in which the sample is spotted, and then wick is dipped into the solvent, and then in circular development, the sample is spotted onto the one circle which is framed there, and then we have given also the solvent run till where the solvent has to run, and then it gets separated, and we measure it from the center, the distance, and the distance traveled by the solvent, and then we find out the Ra value. And then we have a two dimensional. In the next, you can see the two dimensional. In one, what we do, we run towards for one time, and then we turn the paper to 90 degree, and then we run with the same solvent or the different solvent, so that again the separation happen. It can be attended in a more fascinated way, or more sophisticated way, so that the distinguishing between the similar type of compound is easier. So this is the advantage. We have already seen this in a previous video. So here is a pictorial aspect of all those development techniques: circular development, two dimension development, ascending and descending, and ascending development and descending in development. So let us see the after the development, we have to see the visualize the sample, right? So before we go for a visualization of sample, we need to drawing of a chromatograph. Since this is placed in the solvent system, and then what we have to do, the solvent which is present onto the paper has to be dried. So after the solvent has moved to a certain distance for a certain span of time, the chromatogram is taken out of the tank, and position of the solvent front is marked with a pencil, and they're dried by cold or hot air depending upon the volatility of a solvent. A simple hair dryer is convenient device for drying chromatograms, or you can keep into the below the fan, so that the solvent get evaporated, because these are generally organic solvents. So the at room temperature also they can just get evaporated. And when it is only problem when you have a water as a solvent, or you have a methanol, a higher polar solvent, in spite not of even methanol, but water sometime you need to use as a hot air dryer you need to use. Otherwise, at the room temperature itself, the solvent will be evaporating. Then we have a visualizing agent. It is very easy to visualize when you have a dyes, or you have a colored compound after the separation. Otherwise, the separation after the suppression, visualizing a substance is a challenging one, right? If the substance is a colored, they are visually detected easily, but the colorless substance, physical and chemical method are used to detect the spot. They are sometimes they are classified into specific method, and sometime it is specific method. We have seen all this in a TLC also, the specific and non-specific method. Here we will see about the quantitative and analysis of the sample. How do we do it, right? So let us see what are the non-specific method. Non-specific method, we treat it with the sulfuric acid, or we treat it with the iodine chamber, or we see it into the UV chamber, and generally at the wavelength of 254 and 365. But whereas a specific method, depending upon the compound, if you know that what type of compound it is, you can treat with a particular reagent with which you can do the suppression. Like for an example, identification. For an example, if you have a phenolic compound and tannins, you can see it with ferrichloride. If you have amino acid, you can see it with ninhydrin. And when you have alkaloid, it can be seen with dragon drop reagent, right? And cardiac glycoside with 3,5-dinitrobenzoic acid. And in this, it is further classified in destructive and non-destructive method. Destructive method is a technique in which you, when you visualize your sample, thereafter you cannot collect it, right? It is just it get damaged when, I mean, when you have been applying, right? So for an example, destructive technique is a when you are looking for amino acid and you treat with ninhydrin, it forms a complex and gives a color, and which cannot be further used, right? It just help you in detecting the sample, right? In non-destructive technique, the sample can be readily collected after the suppression has happened. Like for an UV chamber, right? It, you just saw the spot, circled it, and you can recollect it, right? Or for when you have a radioactive material, J.R. Muller counter is there, which help you in identifying a compound, and this not destructed, right? Even treating it with a sulfuric acid comes under the destructive technique. So I mean, after the detection, right, you can, I mean, a specific non-destructive technique, we could quantify the estimation that how much is the sample present. It is either a direct technique or indirect technique. In direct technique, we have a different type. We have a fluorometry, we have photodensitometry, or comparison of visible spot. In comparison of visible spot, you should have a standard sample, and you can roughly quantify the component in the mixture has been carried out by comparing the intensity and size of the spot with the a standard substance, and you can know that how much is the substance is present. But whereas in photodensitometry, this method is used with the chromatogram of a colored compound, an instrument that measure quantitatively the density of the spot and find out how much is the quantity present. This is generally done when we do HPTLC. And in fluorometry, the compound can be determined by the fluorometry, by the fluorescence of a compound, or convertible into the fluorescence derivative, and this shows that how much the fluorescence has been shown, and it can be calculated the quantum of the substance present in the in the separated part, right? So this is the method. And then we have other technique through which you can estimate is a radio tracer method. The compound containing radioactive element is labeled and treated with locating reagent using George Muller counter, and it help you in finding out how much is the quantity present. Later on, we have we also have a plographic and acrometric method in which we measure the amount of current or potential different, and that help you in finding out the I mean, how much is the sample present. And this is generally used for depends upon the which type of compound you are separating. For an example, in polarographic and conductometric, the you have a cations or an ion, or which must be a charged particle. In radio tracer technique, you must have a radioactive compound. In a fluorometric method, you must have a fluorescence showing compound. And when you have I mean, densitometry method, you should have a color compound so that you can see the where is the sample. So these are the technique, and there are some requirement for this to be having the quantitative deduction of the sample. In direct method, in this technique, the spots are cut into the portion, right? Suppose what happened, the sample is separated and it is present into the column or it is present into the onto the paper, you cut down that paper, and then what you do, you dissolve into particular solvent, evaporate the solvent, and or weigh it, or you do the spectrophotometry analysis of absorbance, and then you can find out the concentration, or electrochemical method through which you can do it, right? So this is indirect method, which in which what you have to do, you have to cut into the portion and dilute with the solvent, and this solution can be analyzed by technique of analysis like spectrophotometry or electrochemical method. So this is indirect method through which you can quantify the sample present. So these are the method through which you can find out that how the sample and how much is the sample present, right? Then we have RA value. What is RA value? It is a retardation factor in which help us to find out the uh, which help in finding out the how much is the sample present, right? So RF value, the retardation factor, in the paper chromatography, the result are represented by RF value, which represent the movement or migration of a solute relative to the solvent front. So what are the factor affecting RF value? So RF value is a ratio run by the solute to the run by the solvent, right? We take the ratio of the solute and solvent, and in this the factor which affects the RF values are temperature, purity of the solvent, and the quantity of the paper, absorbent impurity present, chamber saturation technique, distance traveled by solute and solvent, a chemical reaction between substance being partition, and pH of the solution. So RF value is one important factor which help in finding out the compound is pure or not. So apart, not only the purity of a sample plays a vital role or match up with the sample. Apart from that, the RF value is being affected by all this. So make sure that when you are taking a study, all this is considered, right? Temperature, purity of the sample, quality of paper, chamber saturation, distance by the solid and solvent, chemical reaction, and pH of the solution all plays a vital role for RF value. Apart from this, we have a RM value which find out the analogous series of a compound, and they tell you that it is a homologous series of a compound, or it belongs to the same family. Then what are the different type of stationary phase? We have a Wattman paper. We have already seen that number 1, number 2, and 4042, and the presence of cellulose and all that, and the factor of choice again. We have discussed all in this in the previous slides. So let us see the error during the application spot, right? So before we go into the seeing the error of our application of the spot, we must always remember the Rx value is the Rx value is always 1. Rx value is the ratio of distance traveled by the sample and distance traveled by the standard, right? So Rx value must be 1 to say that the sample is of same origin or same nature, right? So what are the error during the application spot? Apply minimum volume of concentrated solution in order to avoid diffusion through the paper, which leads to poor separation. Spot must should be approximately at the same diameter. Improper adjustment of paper in the tanks lead to the error, so the paper should be held vertically. Do chamber saturation before detection, and the spraying method affects the result. So make sure all this is taken into the consideration. What are the application of paper chromatography? It help in the separation of mixture of compound. It help in the separation of carbohydrate, vitamins, antibiotic, proteins, identification of drugs, identification of impurities, analysis of metabolites in the drug and urine. So this is how the paper chromatography is applicable, and this is done. So we have discussed here the principle, procedure, and then method of detection, and then a certain term called RF value and Rx value, and the application and the error through which has to be avoided while we are studying. So you can understand that paper chromatography by